We're going to look at the absolute value functions today. The function y is equal to the absolute value of x is the parent function of the whole family of absolute value functions. Y is equal to the absolute value of x. Let's take a look at the graph on our calculator. So I'm going to go to y equals, and I'm going to go to math, and I'm going to arrow over to the number column. And number 1 is absolute value. I'm going to put in the absolute value of x. And when I look at the graph, I see a v. So all absolute value functions are in the shape of a v. And it's actually a piecewise function because it has 3 pieces. If you notice an absolute value function, it's made up of 2 rays that meet at the origin. So if y is equal to 0, if x is equal to 0, or y is equal to x if x is greater than 0. Does everybody see the line y equals x greater than 0? Or y is equal to negative x if x is less than 0. So we have a slope of -1 and it goes through the origin. So we just have the absolute value of x that makes a v. So this graph has a point where the 2 rays meet. The point where the 2 rays meet, in this case, is the origin. We'll call it the vertex. So the vertex is the point where the 2 rays meet. So now we're going to take y is equal to the absolute value of x, and we're going to transform it and move it all over the coordinate plane. So we're going to have y is equal to a times the absolute value of x minus h plus k, where we remember from when we did transformations yesterday that a either stretches or compresses our graph, and it also, if a is negative, will reflect it over the x-axis. And we know that h is going to translate our graph left or right, and k is going to translate our graph up or down. So the vertex is going to be, for the y is equal to the absolute value of x, our vertex is at the origin. But if we translate the graph right or left, then our vertex, x-coordinate of our vertex becomes h. And if we translate it up or down, the y-coordinate becomes our k. So the graph of an absolute value function is always v-shaped. And the v opens up if a is positive and opens down if a is negative. So the a tells us 2 things. First is, does the v open up or does it open down, depending on whether it's positive or negative. And it also, if it tells us the graph is wider than absolute value of x if a is less than 1, or in between 0 and 1, and narrower if a is bigger than 1. So remember, if our graph becomes wider, then we say the graph is compressed. And if the graph is narrower, we say the graph is stretched. So the first thing we're going to do is we're going to do some matching. So I see 3 times the absolute value of x, -3 times the absolute value of x. So these 2 graphs are the same, except one has a v that opens up and one that has a v opens down. And the 1/3 times the absolute value of x is obviously compressed, not stretched. So if the a is 3, we say it's stretched. So that's going to be either b or c. So I think that the one that opens up is going to be b. So 12 is b. And the one that opens down is going to be c. So 13 is c. And the one that's compressed or really wide is a. And also notice that for a, the vertex is at the origin. And if we go up 1 and over 3, we get to a point on the graph. And then also for b, the vertex is at the origin. If I go up 3 and over 1, then we get to another point in the graph. So I think that a is kind of like our slope here. Since our absolute value function is made up of 2 rays, the a becomes our slope of our 2 rays. So the next matching, make sure that we know how to translate a graph either up, down, left, or right. So when I see the absolute value of x minus 2, I know that this graph has been translated to the right 2 units. And then absolute value of x and then minus 2, number 16, this one is going to go down 2. And then absolute value of x plus 2, this graph has been translated to the left 2 units. So now that I know that, so just knowing that, I can match them to the right graph. I can say that 15 is C, and I can say that 16 is A. Notice A has a vertex at 0, negative 2, and the A is 1, so up 1 and over 1 every time. And then lastly, 17 is B. Okay, so the next thing we're going to do is we're going to look at a graph of an absolute value function, and we're going to come up with the equation. Okay, so as soon as I see that the graph is a V, I'm going to write y equals A times the absolute value of x minus h plus k. And so I need three things. First, I need the h and the k, so that comes from the vertex. So for each graph, we can state the vertex. So for number 10, I see that the vertex is at 2, 0. So that tells me that my h is 2 and my k is 0. And then also, I know that I need my a. So from the vertex, if I count up 3 and over 2, I get to another point on the graph. And so that tells me that my a is 3 over 2. Positive 3 over 2 because the v opens up, and my slope of one of my rays is 3 over 2. So my a is 3 over 2. And my vertex is at 2, 0. So I'm going to put the absolute value of x minus 2, and then I'm not going to put a plus 0 at the end because we don't need that. So the next one, I see the vertex is at negative 2, 2. And so I'm going to write y equals, and then I'm going to go from my vertex, I'm going to count down 1 and over 1, down 1 and over 1. So I see that a in this case is negative 1 since my v opens down. My a is negative 1 times the absolute value of x plus 2. Remember, an x plus 2 shifts our graph from the origin to the left. So I need an x plus 2 and then plus 2 for my k. And then one more. So these aren't too bad. So I'm going to state the vertex. My vertex is at negative 1, 2. Negative 1, 2. Fix that. Negative 1, 2. And my a, so since my v opens up, I know that my a is positive, and I'm going to go up 1 and to the right 3. So I know my a is positive 1/3. So I'm going to say y is equal to 1/3 times the absolute value of x plus 1 plus 2. Now notice, since my coordinate's negative, inside my absolute value sign, I have an x plus. Okay, so the last thing we're going to do is we're going to graph an absolute value function, and we're going to label the vertex and we're going to label the intercepts. So the first thing I want to do is I want to look at the equation and I want to determine where is the vertex. So I see that my h is 0 and my k is 6. So my vertex is at 0, 6. So I'm going to plot 0, 6 on my graph. And I see that my a is negative 1. So from the vertex, I'm going to go down 1 into the right one and down 1 into the left one, because remember, the graph of an absolute value function is a v, so I need to go down in both directions. And then lastly, I want to find the intercepts. So I'm going to find the x-intercepts, and I'm going to find the y-intercepts. And I can see on the graph that the y-intercept is at 0, 6. So I'm going to show the algebra that proves that. I'm going to solve for y when x is 0. And I can see that that number is definitely 6. So my y-intercept is 0, 6. And then lastly, I'm going to find x-intercepts by making the y 0 and solving for x. So I'm going to make some room here. I'm going to say 0 equals negative 1 times the absolute value of x plus 6. So now I'm going to solve for x. So I'm going to get the absolute value sign by itself first by subtracting 6 from both sides. And then I'm going to divide by negative 1. So I get the absolute value of x is equal to 6. So if the absolute value of x is equal to 6, that means either 6 or negative 6. So I have two x-intercepts, 6, 0, and negative 6, 0. So I'm going to go over to my graph and make sure I have those points. 1, 2, 3, 4, 5, 6. So 6, 0. 1, 2, 3, 4, 5, 6. Negative 6, 0 there. So I found the vertex, and I found the x-intercepts and the y-intercepts, and I drew my graph. So we're going to do one more. So the next one says 1/3 times the absolute value of x minus 3 plus 4. So I'm going to state my vertex. I see my h, k is 3, 4. Remember, if it says x minus 3, then that means that the vertex is shifted to the right 3 units. So I'm going to go 1, 2, 3, and then up 1, 2, 3, 4, and make a vertex. And I see that my a is 1/3. So to get two other points, I'm going to go from the vertex. I'm going to use my A as my slope. I'm going to go up 1 and over 3. And then I'm going to go up 1 and to the left 3. And then draw my graph. Now I notice two things. I have to have my x-intercepts and my y-intercepts. So I notice first that the y-intercept is at 0, 5. But I'm going to need to algebra to prove that. So I'm going to show that when I plug in 0 for x, that I do get 5 for y. So I'm plugging in 0 for x. The absolute 0 minus 3 is negative 3. The absolute value of negative 3 is 3. Well, let's just write 3. And so 1/3 times 3 is 1, and 1 plus 4 is 5. So the y-intercept is 5. And then now I'm also going to look at this graph, and I'm going to decide that this graph will never cross the x-axis. So we can say with confidence that there are no intercepts. But I am going to want us to show some algebra to prove that. So I'm going to plug in 0 for y, and I'm going to solve for x. So I'm going to first get the absolute value by itself. So I'm going to subtract 4 from both sides. And then I'm going to multiply both sides by 3 to get rid of that 1/3. And I get the absolute value of something is equal to negative 12. And so we know that the absolute value of something will never be 12. So that tells me there is no solution to this equation. So therefore, there are no x-intercepts.